Okay, today we're going to talk about 0.6, which is rational exponents and radicals. Our objective is to understand how to simplify radicals, rationalize denominators, and apply properties of rational exponents. Okay, so a square root and a radical are the same thing. So if I give you this symbol here, let's say I give you this symbol. Okay, most of you will call that a square root with a small 2 right there. And then we have a third root and a fourth root and so forth and so on, which you've dealt with before. Okay, well, with radicals, the actual symbol itself here is called the radical. Okay, we have our index out front, which tells us how many in a group. And then we have our radicand, which is the number underneath our radical right here. So in this case, 4, 8, and 16 are our radicands. Our indexes are 2, 3, and 4. Okay, so what do I mean by how many in a group? Well, if we go back up here to the square root of 4, I need a group of 2. So what number times itself twice will give you 4? Or over here at the 16, what number times itself 4 times gives you 16? And in fact, all three of these are equal to 2. So 2 times 2 times 2 times 2 would give you that 16. So there's a group of 4 2's there. All right. So then we want to evaluate the real roots. Okay. Keyword being real. Okay. So if I look here, I've got an index of 2, okay, meaning I need a group of 2. So what number times itself will give you 169? That would be 13. Now here I've got division. Okay, and we'll talk about this property in a second, but most of you already know that I can take the square root of 4 over the square root of 9. And the square root of 4 is 2, and the square root of 9 is 3. Okay, so this is 2/3. With the square root of negative 36, again, there's a 2 right here. So what number times itself will give you a negative 36? Now, it's got to be the same number. So you might say, well, negative 6 times 6. Well, see, these two numbers are not the same. Okay? Therefore, I can't have the square root of negative 36 being plus minus 6. If we say negative 6, that's still positive 36. And if we say 6, that's positive 36. So there's no way to get this negative number right here. So we'd say this has no real roots. Okay, that one has no real roots. Now we've got some properties here to talk about. This one we've already talked about. If I've got a fraction in here, I can split up the top and bottom and take those radicals separately. Same thing, and I can go the opposite way. Okay, this is both directions. Same thing here with multiplication. We can go both directions. If I have multiplication underneath, I can split it up into 2 separate multiplications. And if I got 2 separate, I can go back the other way. Okay, but this stuff right here is probably the newer stuff for you. The square root of x squared is the absolute value of x. It cannot be a negative number. Okay, I can't have a negative number in here. So anytime I have an even exponent or an even index and an even exponent, that's when we're going to simplify using the absolute value of x. Okay, if I have an even and an odd, so an even index and odd exponent underneath, we have to say x is bigger than or equal to 0. And let's look at why that is. Okay, so let's say we have the square root of x to the third. And I just pick a random number for x. I pick, let's say x is negative 2. Okay, so when I substitute that in, we'll get the square root of -2 to the third. Well, -2 to the third is the square root of -8, and I cannot have a square root of a negative number. This is non-real. And I only want to look at real numbers. Well, if I say that x has to be bigger than or equal to 0, I get rid of all these negative numbers here, making all of these real solutions. So that's good. Now, if I have an odd index, and if this is odd or even, it doesn't matter what x is. With an odd index, I can have negative and positive numbers under there. Okay, it is just fine. Okay, so let's look at some here. Now we're going to look at these a little bit different than you probably did in Algebra 2. Okay, again, if there's no index, it's a 2. Okay, so I have an even index and an even power. That's when I use the absolute value of 6. Okay, this number here, which is 6. Even index, even power. So I have the absolute value of -7, which is 7. Now we can look at this maybe an Algebra 2 way. We would say the square root of, well, -7 squared is 49. And then the square root of 49 is 7. And then this is just our definition here. The square root, I got an even and an even. That is the absolute value of x. Has to be absolute value. Okay? Because if I put in -2 squared and then the square root, well, -2 squared is 4, and the square root of 4 is 2, so it is a positive. So if I take the absolute value of that, I get 2. If I don't take the absolute value, I get -2, and these do not match. Okay, so we got to take the absolute value. Simplify. Again, we want to look at the indexes first. So this is a 2, so I have even, so I'll be using the absolute value. So you might just make a note absolute value x up here. That lets me know I'm going to be using absolute value if I can bring any x out. Okay, and this tells me I need a group of 2. So if I break 48 down, that's 2 and 24, that's 2 and 12, 2 and 6, 2 and 3. Okay. So I need a group of 2. So I've got this group of 2 and this group of 2 numbers, and I got a 3 left over. I also have a group of 2 x's right there. So I'm bringing one of each of those groups out to the front. So I've got 2 times 2 times the absolute value of x. Remember, we noted that up there. Times what was left underneath the radical, which was this lonesome 3. Okay, which reduces to 4, absolute value of x, radical 3. And there's our solution. Okay, if we look at the one on the right here, I have an even and an odd. If I have an even and an odd, we can look back in the notes that says x is greater than or equal to 0. That is my domain. That's what I can choose for x. So now I can simplify. So I need a group of 2. So we'll do 2 and 16, 2 and 8, 2 and 4, 2 and 2. So there's a group of 2, there's a group of 2, and I got a 2 left over. Now, I need a group of 2 x's, so I'm going to rewrite x to the third as x squared x. So there's a group of x's. So again, each one of these that is circled, I'm going to bring out one of those numbers or letters. So I'm bringing out a 2 and a 2 and an x. What is left underneath my radical are the numbers that are not sorted or not into a group. Not the ones I've broken down, okay, the ones on the end. So I've got 2x underneath. So I've got 4x, radical 2x. And we don't need absolute values because I've got this domain here. I've got this domain up here of greater than 0. We made a mistake here. This right here. 28 breaks down to 2 and 14 and 2 and 7. That's my fault. So we'll say I'm bringing out a 2 and a 7 is left underneath. Okay. So we have 2x radical 7x. There we go. Sorry about that. Okay, so we've got multiplication here. We need to look at the index and the power before I combine anything. So I have an even and an odd. So that tells me x is greater than or equal to 0. Okay, so now since I have multiplication here with two radicals of the same index, if they weren't the same, I couldn't do this. We're just going to multiply what's underneath. So I have the square root of 12 times 6, which is 72, and x times x is x squared. So this is part of my answer. I can go ahead and circle that up. And then we're going to break down 72. So I've got 2 and 36, 6 and 6. Okay. So I can keep going down here, but I notice that these two are already the same and the 2's left over. So I can stop there. And then I'm going to circle my x squared because there's a pair there. So what comes out? I got a 6 that comes out, and I got an x that comes out. And I'm left with the square root of 2. Plus my domain from the front. Okay. Now looking at this division, okay, I've got even, odd, even, odd. So here we're going to say x is greater than or equal to 0. Go ahead and circle that one. With division, I can put them under one radical since the index is both 2. So we've got 45x to the third over 5x. Well, 45 divided by 5 is 9. X to the third divided by x is x squared. And then the square root of 9 is 3. The square root of x squared is x. Since we already said that. Had we not said this already, we would say absolute value of x. But we already know it's got to be positive from that statement right there. All right, simplify. Looking at the index, we've got odd. So anytime there's an odd out here, it doesn't matter what x is. But this tells me I need a group of 3. Notice this negative under here. So we're going to bring out a negative number. So let's say -2, and that would be 12. Now I want a group of 3 negatives because I don't want to leave a negative under this radical. I want to try to bring that out if I can. So we'll bring out a -2 again. In this case, -6 with it, -2 and 3. So here's my group of 3 numbers. Now the x to the 5th can be x to the 3rd. There's a group of 3, and I have 2 left over. So I'm bringing out a -2x, and under my 3rd group, make sure we get that index written there. I got a 3x squared. And that's my solution, my answer. Now make sure we leave enough space here so that we're not thinking x to the 3rd square root there. All right, so I need a group of 4. So I have even, odd. So if I have even, odd, that tells me x is greater than or equal to 0. Now, sometimes you have to watch this. Up here, we made a mistake here and said equals 0. Well, if I equal this to 0, okay, and I pick 0 down here, this whole term becomes 0, so it's undefined. So we need to go back up here and change this to x greater than. Okay, so you gotta watch that. It will sneak up on you like it did us. So here I need a group of 4. So I got 32. That's 3 and 16. Not 3. That's 2 and 16. That's 2 and 8, 2 and 4, 2 and 2. So I need a group of 4. That's 1, 2, 3, 4, and 2 left over. X to the 5th becomes x to the 4th, x. So there's a group of 4 with 1 left over. So I'm bringing out a 2 and an x, and I have the 4th root of 2 and an x left underneath with this. And I can equal 0 because I don't have an x on the bottom anymore. Okay, perform the operation. We can only add and subtract if 2 things happen. Number 1, same index. And number 2, it has to have the same radicand. Okay, so the same number on the shelf and the same number underneath. So in this case, I've got square root of 3, square root of 3, square root of 3. So we're good. Then I just follow order of operations and combine like terms. So I got 4 minus 6 is negative 2. Negative 2 plus 7 is 5 radical 3. All right. Here I've got square root of 5, square root of 7, square root of 3. Well, even though my indexes are the same, my radicands are not the same. So I cannot add because radicands are not the same, are not equal. Okay. Here, I've got the 4th root of 10, 3rd root of 10, square root of 10. My radicands are the same, but my index numbers are not the same. So those are totally different answers there. So in this case, we'll say cannot add because index not equal. But at first glance here, you notice that all the indexes are the same. They're all 2, but my radicands aren't the same. But what we have to look for is, are these radicands reduced as much as I can? Well, square root of 5 is reduced because that's a prime number. I can take 4 and 5, 2 and 2, so I got a group of 2 there. So we'll have 3 radical 5 plus 2 radical 5. So now these 2 are the same. Well, 45 breaks down 9 and 5, 3 and 3. So there's a group. So I already had a minus 2 out front. So I'll take minus 2 times 3, get negative 6 radical 5. Now if we look, they all have the same index and same radicand. So I can definitely add those together. So I have 3 plus 2 is 5, minus 6 is minus 1, radical 5. And we're finished. We cannot leave radicals in the denominator. It's just not proper for the most part. There will be some cases where you do want them in the bottom, but for the most part here in college algebra, we don't want them on the bottom. We fix this by rationalizing the denominator. If the denominator contains a sum, we use what's called the conjugate. Okay, so if, let's say this is z, and we'll say z bar will be the conjugate. In order to get rid of this term, let's say it's on the bottom somewhere, we want that off of there. We have to multiply this by something called the conjugate. But what the conjugate is all I have to do is change this middle sign. And what this does is it creates it into a difference of squares. And remember, on difference of squares, we have this a squared minus b squared equals a plus b, a minus b. And my middle 2 terms cancel out, and I square both of them, which would get rid of my radicals. So that's what I want to do. And notice there are 2 terms here and 2 terms here. And then we will FOIL. So z bar would be 3 minus radical 5. And then z bar, which is multiplying these 2 together, we have 3 plus radical 5, 3 minus radical 5. And I would just FOIL this all out. Okay, so I get 3 times 3 is 9. 3 times minus radical 5 is negative 3 radical 5. Radical 5 times 3 is 3 radical 5. Radical 5 times negative radical 5 is negative radical 25, which is 5. Okay, so here you have minus 3 radical 5 plus 3 radical 5. Those go away. you have 9 minus 5, which is 4. So it goes away. And then in this case, z bar would be a minus square root of b. Okay, this. And then my radicals would go away. Again, I'd have to do this to the top. I can't just multiply by the bottom by that number there. And I don't think I'm going to talk about it later, but let's talk about it real quick. If I just have the radical on the bottom, let's say I had 7 over 2 radical 2. I can't have this on the bottom, but in this case, instead of multiplying by the conjugate, I just multiply it by radical 2 on the top and the bottom. Notice here there were 2 terms. Okay, so I got to multiply by 2 terms. Here there are 1 term, so I got to just multiply by the 1 term. Okay, so I get 7 radical 2 over, this becomes 2. I already had the 2 out front, over 4. Okay, so now my radical's off the bottom. Okay, rationalizing the denominator and simplifying. So here, I did have one here. So we will get rid of this. Since there's only 1 term, we can just multiply by radical 10 on top and the bottom. Okay, so on the top, I'll have 2 radical 10. And on the bottom, I have 3 radical 100, which the square root of 100 is 10. 3 times 10 is 30. So I have 2 radical 10 over 30. Okay. Now I need to see if I can cancel. I cannot cancel the 10 and the 30 because 10 is under the square root. So I'm going to cancel the 2 and the 30 and make that a 15. So in the end, I got radical 10 over 15. And we're finished. Okay, for this one, since I have 2 terms, I know I got to multiply by 2 terms, and in this case, it's the conjugate. We have to have that difference of squares. So 3 plus radical 2, 3 plus radical 2. So in the top, I'll just distribute that and get 15 plus 5 radical 2. And in the bottom, we'll do first, we get 9. Last, we get 3 radical 2. Inside, we get minus 3 radical 2. And last, we get negative radical 4, which is 2. The middle 2 cancel out, so you have 15 plus 5 radical 2 over 9 minus 2 is 7. And we can't cancel anything. Okay. I couldn't cancel, let's say I have something like this. Let's say we have 12 plus 6 radical 2 over 3. Well, I can't just cancel these 2 or just cancel these 2. I got to cancel all 3 of these terms at once. So in this case, it'd be 4 plus 2 radical 2. That would be my solution. Or this was maybe a 4. I couldn't cancel the 12 and the 4, okay, because this isn't divisible. The 6 is not divisible by 4. I got to cancel all terms in the top. All right, so I have 2 terms on the bottom. So I have radical 2 plus radical 7. And we'll do the same thing to the top. So we distribute this, and we FOIL this out. So on the top here, I have radical 10 plus radical 35. Okay, so I do the first, so that's 2, because my radicals cancel out. And I have plus the square root of 14 minus the square root of 14 minus 7. Those cancel. You get 2 minus 7 is minus 5. Radical 10 plus radical 35. And I can't break these down anymore. Okay. But I also can't cancel the 5s because these are under the radicals. This is not. Plus this addition sign prevents me from doing that. Common question is, how do I know when I'm done? I don't know when to stop. Well, this is when. No factor has an exponent greater than or equal to the index. So if I have the third root of x to the 7th, this power right here is bigger than my index. I am not done. We can cancel this. How many groups of 3 can I take of 7? Well, 2 groups with 1 left over. Okay. Denominator does not have a radical. That's the stuff we just talked about. I cannot have 2 over radical 3. That's not proper. You get that off the bottom. The radical does not have a fraction. We're going to talk about that. And power of the radical doesn't match the index. Okay, we'll talk about that later on too. So simplify. So we're nice enough here to get our domain, so I don't have to worry about that anymore. Plus, I don't have to worry about, okay, it's even, odd, okay, all that. I don't have to worry about that. If they didn't give that to me, then we would look back for it. Okay, so I've got a fraction in here, so I'll split it up top and bottom. So I'll take the square root of 16x to the 5th and the square root of 81y to the 7th. Well, the square root of 16 is 4. And how many groups of 2 can I make out of 5? So I can make 2 groups with 1 left over. Okay, square root of 81 is 9. How many groups of 2 can I make out of 7? Well, I can make 3 groups with 1 left over. Now you might say, wow, that was really easy. But notice here I have a radical on the bottom. Okay, I got to get rid of that. Because it's a single term, we'll just multiply by radical y. So on the top, we have 4x squared radical xy. On the bottom, we will have 9y. Here was 3, and this creates one more y, so we have y to the 4th. And we finish that one up. Okay. There's really one. We don't need to memorize this property. Let's remember this property here, because if we can get this property, we can definitely get this one very easily. Okay, so I have a to the mn, a fractional exponent, equals the nth root of a to the m. That's a little confusing. So let's notice here. My m goes to the inside of my radical. So we'll say inside. My n stays outside up on the shelf. So we'll say out. So I simply call this inside out. Okay, so I have a to the mn. M goes to the inside, n goes to the outside. Okay, so that's switching from a rational exponent to a radical. Inside out. You need to know that. So I have 16 to the 3 over 2. Again, this is inside out. So 16, 3 goes to the inside, and the square root, there's a 2 there, goes to the out. Well, I need groups of 2, so I'll split it up. The square root of 16 squared times 16. Well, would you agree that 16 squared times 16 is 16 to the 3rd? And looky there, there's a group of 2 right now. Then I'll break this down, 4 and 4. Oh, look, there's another group. So I'm bringing out a 16 and a 4, but there's nothing left underneath my radical. So 16 times 4 is simply 64. Our next one here, it's important that we realize we've got parentheses in the negative here. If we didn't, it would change our answer. So inside out. So we have the 3rd root of negative 8 squared. Again, in parentheses, keep it there. Well, how many groups of 3 can I make out of 2? Well, I can't make any, so I have to multiply this now. So the 3rd root of negative 8 times negative 8 is positive 64. And the 3rd root of 64, what times itself? 3 times is 64. Well, we can break it down if we need to. And there's my group of 3 right there. So 4. Hopefully you know that that is 4 by just looking at it. That's one of those things you should have memorized. All right, so I've thrown in some negative exponents here with parentheses and without. In order to get rid of this negative exponent, I have to move it to the other side of my fraction bar. In the top case, I'm moving both the 9 and the x because this negative goes with both of these. In the bottom, I'm just going to move this x. The 4 does not go with this negative 3 over 2. Okay, so the 4 stays down. The x to the 3 over 2 goes to the top. The 9x to the half goes to the bottom. All right. Well, here I have 9x, and it's being repeated half number of times. We have x to the 3 over 2. We have 4. Well, if 9 is repeated half number of times, that'll be 3. It's a square root. And then x will be x to the half. So I get 12. And notice I have x on the top and the bottom. Well, where are there more x's? Well, there's half down here, and there's 3 over 2 up here. So there's more x's on the top. How many more? Well, 3 over 2 minus 1 over 2 is 1. So x over 2 is your answer there. Now, I'm not worried about domain on these. I will tell you when we're worried about domain. I will ask for the domain. But these are a little more difficult, so we're not going to necessarily worry about it. You should know automatically that I can't have 0 here for a domain. All right, so here we go. Now remember, we never distribute these exponents. Okay, I'll show you another way that different than this one that we can look at these. Okay. Now the 1/3 power, the 1 goes to the inside, the 3 goes to the outside. So I have the third root of -8 x squared y over 1 goes to the inside, 2 goes to the outside. The square root of 9xy. Well, the third root of -8 is -2. How many groups of 3 can I make out of 2? None. How many groups of 3 can I make out of 1? None. So I've got the third root of x squared y. The square root of 9 is 3. I can't make groups of 2 out of x and y. So I leave that one in there. But I cannot have a radical on the bottom. So I'll simply multiply by xy, multiply by radical xy on the top. And I cannot multiply these two together either, because this has an index of 3 and this one has an index of 2. So it stays the way it is. And in the bottom I have 3. These two halves will make a whole xy. And then there's my answer. Okay, again, we're not worried about domain on these problems. So let's make it a little bit harder here with some factoring stuff that we've talked about. Now, if you just look at this problem, you might realize that it's pretty hard, okay? But if you go back to the factoring steps we talked about, the first thing we look for, number 1, is GCF, your greatest common factor. Well, how many x's go into each one of these? That would be x to the 2/3. Okay, it's your smallest exponent that you're bringing out. Well, if I have 8/3 and I take 2/3 away, I have 6/3, which is 2. If I have 5/3 and take away 2/3, I have 3/3, which is just 1. If I have 2/3 and take away 2/3, I have 0. X to the 0 is 1, so I have 6. And then we'll say x 2/3. Factor this again. Factors of 6 that subtract to 5. Excuse me. That's 6 and 1. X and x. Signs are different, and the bigger one is negative. So just because I added fractions in the exponent does not change your process of factoring. Still GCF and still look for those factors. Okay, so here's your suggested problems. We got a homework quiz change. Problems will be the same concept as the homework problem, but they're not going to be word for word anymore. Makeups will be different, and classes will have different problems. Makeup is when you come in before or after school, if you are gone to take a test. Okay? All right. Thanks for watching. This is at THS Mr. Jones signing out.